Nach Peters spannenden Dingen, die er nicht erzählt hat, freuen wir uns jetzt auf einen Vortrag, der darum geht, wie man die Dinge noch komplizierter macht. Und zwar bin ich sehr erfreut, dass Dr. Clint Hansen vom Landesklinikum Schleswig-Holstein oder Uniklinikum Schleswig-Holstein zu uns gekommen ist und einen Vortrag hält. Der Clint hat auch bei unserem letzten User-Meeting in Genf einen Vortrag gehalten und hat eine lange Erfahrung mit IMUs und Sensorik und nutzt diese zurzeit in der Neurogeriatrie. Herzlich willkommen, Clint Hansen.
Thanks a lot. Can you hear me all in the back? All good? Yeah. Perfect. So, when I started putting this whole thing together, I realized that unnecessarily I make my life more complicated just because sometimes I click too many buttons. And the problem also is that Peter somehow came into my life. But let's start from the beginning. So we are from Kiel, Neurogeriatrics. And what is Neurogeriatrics? First of all, I don't have any conflict of interest. So we in Kiel, a few years back, we had a big definition, what is neurogeriatrics for us, how can we define it, how can we help all elderly people with neurological diseases to get better. So in the US and English-speaking countries, neurogeriatrics is a relatively normal term. Neurogeriatrie in Germany is relatively new. So in Kiel we had one of the first wards for neurogeriatrics. So we have more or less 20 beds, and what we can do with our patients is we can also do research because we're a university hospital. So that's just to set the stage. We have relatively fit patients, but also we have terribly sick patients as well, which you can see based on a little illustration here. So for us, movement is a biomarker. I think we all agree on that based on, we're just looking at a patient or a person and we can see more or less how well the person behaves. We just had the discussion about lower back pain. I kick you on the shin. I know exactly you're walking very funky for a few minutes, or last night when we had a couple of beers, everyone was walking a bit shakily. So we can just see it by looking at the person. We get a good idea about the kinematics of the person, but we can also, if we go a bit deeper and we dig a bit deeper, we can get a really good insight of the status of the musculoskeletal system. So we as physiotherapists, sports scientists, researchers, doctors, we obviously can have a look at the movement and the person on multiple layers and multiple levels. So for example, in neurogeriatrics, what we can do, we can look at the tremor of the hand, we can see how bad is the person shaking, or we can just have a look how rigid certain joints are, or we can go even deeper and we do a gait analysis, what we have seen quite often today. And if we're really, really motivated, then we do a 3D full motion capture, as we've seen with the THEA, for example. And also what we could do is the musculoskeletal modeling, which is rarely happening in elderly people at the moment. So the tools that we have, obviously, we all know that, and this is why we're here. We want to objectify things. We want to measure things objectively. We still need clinical expertise. Most of the time, the doctors don't have really time to go into a really, really big development or like an evaluation using EMG or IMUs. So they mostly rely on their clinical expertise. In sports, we know that a lot, the coaches, they see someone and they think they know exactly what they have, what injury they have. We call it the iometer because you can't see what the person has. And just your expertise doesn't really allow you to understand the physiological problems that the person actually has. And then obviously we have stopwatches and those kind of small tools. In the clinic where we work, we have multiple options to measure our patients. We have a qualysis system, we have a few other IMU systems, also the Noraxon system. But the interesting part for us is we have the option either to use the lab or we use the IMUs. And that is the point that I'm really trying to focus on today, is we want to understand where can we use the IMUs and can we actually use them on the ward, for example. So as we all know, IMUs provide information about orientation in space, and based on the inverse kinematic model, we also can create the skeleton that everyone knows and has seen multiple times now. So the inertial measurement units, or IMUs, the low cost obviously depends on what system you buy and how the software package is. But if you use IMUs, most of the time it's quite complicated if you want to go into really critical research or complicated research. If you're just putting an IMU, as we have seen, I think yesterday, just on the pelvis for biofeedback, or it was today, I don't know, then it can be relatively easy. The problem, though, is when we want to use it in the clinic and we want to use it for research purposes, we need to get really, really good signals. The problem that we have, though, is that most of the time when we do longer measurements, everyone may have noticed that the IMUs start to drift. We have a strong drift in the signal. So that's a problem, because we cannot, most of the time, measure our patients in the movement analysis lab. Why? Because it's in a different building. So we just moved, and our ward is basically 200 meters away from the lab. So if I take a neurogeriatric patient, an old patient, and we walk 200 meters, then the person cannot do any physical examination at all. Most of the time, they refuse to be taken in a wheelchair. So that means, where are we measuring them? We need to measure them on the ward. But the problem on the ward is the ward and everything changes constantly. Sometimes there is a bed in the middle of the corridor where we want to do our gait analysis. Sometimes there are people, then they serve lunch. So it's quite complicated, and we get a lot of magnetic distortions. So we never have a lab where nothing ever changes. So recently Noraxon came up with the functional calibration approach. And the functional calibration approach allows us actually to align the skeleton. So I'm not going into the details. That is Peter's job, maybe, if you want to ask more questions about that later. But basically what it does is it tries to remove the drift, which would then eventually allow us to use the system on the ward. So we tried that. And then this is where, unfortunately, I get a call from Peter. Peter said, listen, can your patients actually perform the functional calibration? So the functional calibration consists of a relatively easy task for us. We just stand very still. We walk a few meters, do a 180 degrees turn, come back, and stand again in a very straight pose. I think we call it soldier pose. Can they do that? Yes, of course they can. But just telling Peter, that obviously doesn't work. So we have to come up with a study and try to prove that it really, really works. So, and this is why I mean it's getting complicated now, because I think they can do it, and it's such an easy task for them to do. So then I get into thinking. Play around with the myoMotion software, and I end up, unfortunately, with those interjoint angle-angle plots. I love them, but I don't know what they mean. So I understand that they can be of extreme interest. And yesterday we talked about tennis, and unfortunately, 2014, I had to analyze tennis players with a normal optical motion capture system. So, and I realized when I just plotted the rotation axis of the shoulder that the players move so differently, even though the task was exactly the same. They had to play at the same speed, always in the same corner, but the movement patterns of each individual are so different. So the question now is, cool, we can see it, we can break it down maybe to a number, but what are we doing? Can we actually quantify it in a better way? This is then where John, the poor guy in South Africa, gets my call, and I ask him, hey, do you think we can quantify this also in neurogeriatric patients when we try the soldier pose on the functional calibration? We got a bit into thinking, and then there's a poor MD student in Kiel who had to actually do all the work. while we were just sitting behind the PCs and were doing then the calculations. So joint coordination quantification is still for me quite complicated. Basically what it is, you're looking at the different segments and when and how they're moving with regards to each other. So Jocelyn Harth and Catherine Boyer, who we've been in contact with to understand it a little better, because in their articles they use 8 different methods to calculate their face angles. Basically what you do, you're plotting the joint angles, and then you get, as I wrote here, the face angle were calculated as the angle of a vector connecting consecutive data points in each angle plot with respect to the right horizontal. So basically what you have to do in the myoMotion software, you are exporting the data slightly different. This is not something that everyone can do. It's just John did it for us in this study. And it allows you to understand if patients or people behave differently. So, and Catherine Boyer showed that older, high active patients and young, older, less active patients, they actually move completely differently. So they get their hip flexion from different strategies, which is quite interesting. So I thought maybe we can play around with it and get it done in our patients. So the arrows indicate the rotation, right, of the segment. So, and the findings of this study were that hip flexion and terminal swing, so then obviously we have to look into the Perigate cycle and we have to determine specific points. Maybe you haven't seen this, I was too quick. For example, you can determine where the heel strike is. You can't see. So basically heel strike is here, toe off is here, and then you can define the angles at that moment, and then you can identify if the segments move according together or if they move against each other. So that was the idea. Still very complex, and I'm still not quite sure if I really understand and grasp what that really means. In this study, I think I understand it, but in our study, it's massively complicated. So what did we do? So we recruited 50 adults, neurogeriatric patients, and we performed also the short physical performance battery, which is a relatively simple test, which allows you to identify if patients are fit, have good static balance. So there are 3 static balance tests. There's one walk test that gives you an idea about how well people behave dynamically. And then you have a 5 unassisted chair stand or chair rise test, which gives you an idea about their force or their power. This test, we have to say also, we implemented in myoMotion. So the next step then will be eventually that we can score the whole thing in automatically in Noraxon, get a report out, so that the next step is then every clinician can do the same standardized test. That's ideal. So, in order to do that, it was a bit too much for what we did. We used 7 myoMotion sensors, sampling rate at 100, and then we did the functional calibration with all our patients. So, the first question that Peter asked was, can they perform it? Yes. All our patients could perform the functional calibration and do the SPPB afterwards. So, and the SPPB is ranked from 0 to 12. 0 means you're terrible, 12 means you're relatively fit. So, that means now, when we are looking at the data, I'm sorry, it's really, really small. But first of all, I thought, let's look at the range of motion first. Because range of motion is something that I understand, at least. I understand what did you do with your feet or with your hip or whatever. So, and I was positively surprised that the better our patients are, the more range of motion they have in their joints. If you think about it a little more, it's not that surprising, right? If I walk relatively normal, but if a patient with Parkinson's walk, they don't have a lot of range of motion, and they will eventually also have a relatively bad SPPB score. So that correlates well. Is that surprising? I'm not so sure. But it shows that we can, with our functional calibration, do all the examinations on the ward, get the scoring out of the SPPB, and then see that the range of motion is good. So now comes the complicated part, and this is very small, and I'm really thankful actually for it, because Now it's the big question for me. You can see maybe those scatters. There is no trend whatsoever. So if I wanted to look now into the joint coordination, to be honest, I have absolutely no idea. And this is what I was thinking, is that we as a community, you guys need to help me now to understand joint coordination. Because does that make actually sense to use this joint plots in the software? Or is it just a nice visualization? Or is there another idea to quantify it? Maybe it's completely stupid what we did. But so far the preliminary results show there's nothing. So there's no change if you are behaving if you're well, or if you're really, really bad. And I think that is quite surprising. That means, but also, that we have to dig way deeper into this whole joint coordination. I'm not sure if, from a physiotherapist point, if that is interesting or not. I was just pushing buttons, then I stumbled across this whole angle-angle idea, and then we played around with it. But now we are kind of in a cul-de-sac, so we don't really know what we're doing with this data. Is this interesting for you guys? I think it could be interesting. It has a potential, but to be honest, I really don't know how to interpret those data points that we just showed. They were really small as well. So if I'm summing up this little talk, it's really, for me, the functional calibration works, and I think that was the main idea that we had. We can actually use the myomotion system on the ward. We can use it, they can perform it, and then we can any kind of gait analysis. That's very easy. For the interjoint coordination, I think it has potential, but then again, I'm really not sure how we can quantify it so that we, in a few years, discuss a certain value, and we all agree that this is very important, and this is good, and the joints are working cohesively in one direction or not. I don't know. But also what I think, and this is what I was asking yesterday multiple times, is when we are just reducing our values that we get out of a certain test parameter, just the range of motion or just the maximum or mean, it's a problem because we are always neglecting the time series. So yesterday we had the HQ ratio, I think, and we are always looking at the max value. Is that the best idea? Or should we maybe just compare the whole time series? I think that makes more sense because then we can understand where the problem lays. And this is, for me, the same with the interjoint coordination. Do we need now to break it down into specific time points, or are we looking at the whole gait cycle? I'm still not sure, and I really don't know where to start or what the next steps could be. So this is really just throwing it out there. You can use those reports, great, but to be honest, what are you going to tell your patients afterwards? Look, you have very nice curves, and look, left is slightly different than right. You can always explain it with the time series that you have with the normal gait report, but the real question is there something else that we can use in order to visualize how a patient is moving? And I think with this, I thank you very much, and I'm happy to discuss what we did.